Welcome everyone! Today we are going to delve into one of the most powerful and, I would say, elegant techniques in our algebraic toolkit, completing the square. Now, you might be wondering, why is this so important for me as a business major? Well, think about it. In the business world, we are constantly building models to understand things like profit, revenue, and cost. Very often, these relationships aren't linear, they're quadratic, forming a parabolic curve. The ultimate question is often, where is the peak of that curve? Or what's our maximum possible profit? Completing the square is the fundamental method that allows us to find that vertex, to transform a complex model into a clear, actionable answer. So let's begin.
I want you to think about this process not as a dry formula, but as a puzzle. Imagine you have a complex financial forecast laid out in front of you. It's almost complete, but there's a gap. There's one piece of information missing that prevents the whole picture from making sense. Completing the square is our method for precisely calculating the shape and size of that missing piece. Once we find it and fit it into place, the entire model becomes coherent and, importantly, solvable. It's a beautiful, logical process of creating wholeness from parts.
So this is our goal. This is the completed puzzle we aim to create. It's called a perfect square trinomial. As you can see, it's an expression that can be neatly factored into an identical binomial squared. Now, why is this so special? Because its power lies in its symmetry and its simplicity. For example, the expression x squared minus 6x plus 9, well, that's not just three random terms. It elegantly collapses into x minus 3 squared. By transforming a messy equation into this perfect form, we make it fundamentally easier to analyze and solve.
All right, let's ground this in a concrete case study. For the rest of this lecture, we will be working to solve this quadratic equation, x squared minus 6x minus 7 equals 0. Now imagine this represents a break-even analysis for a new product where x is the price point in dollars. We're asking, at what price points does our profit become exactly 0? Looking at it now, the answer isn't obvious. This is our puzzle, and it's our job to find the missing piece that will unlock the solution.
Here is our strategic plan. In business analysis and in mathematics, having a structured, repeatable process is absolutely critical and ensures accuracy and clarity. We will follow these 5 steps in order. This isn't about rote memorization, it's about understanding a logical workflow that reliably takes us from a complex problem to a clear solution.
So, our very first action item, we need to prepare our equation. A good analogy is clearing your desk before starting a major project. To properly construct our perfect square, we need to get everything out of the way except for the core variable terms we're working with, the x squared and the x terms.
So how do we do that? We take the constant term, in this case the minus 7, and we effectively move it to the other side of the equation. Of course, we do this by performing the inverse operation. We add 7 to both sides. The result, as you see, is x squared minus 6x on the left and a positive 7 on the right. Now, the left side of our equation is perfectly prepped, a clean workspace ready for us to find and install our missing puzzle piece. Okay, now for the most critical step in the entire process. This is the heart of the technique. We need to calculate the one specific value that will turn the expression on the left, x squared minus 6x, into one of those beautiful perfect square trinomials. This isn't guesswork, it's a precise calculation based on the structure of the expression itself. The formula for finding this missing piece is always the same for this form of quadratic. You take the coefficient of the x term, which we call b, you divide it by 2, and then you square the result. So, in our equation, x squared minus 6x, the value of b is negative 6. Following our formula, we take that negative 6 and divide it by 2. That gives us negative 3. Then, we complete the last part of the formula. We square that result. So, negative 3 squared. Now, be very careful here. This is a common place for a small error. A negative number times a negative number results in a positive. So, negative 3 times negative 3 is positive 9. This number, 9, is our so-called magic number. It's the keystone that will complete the structure on the left side of our equation. Now, we have our special number, 9, but we can't just drop it into one side of our equation. The single most fundamental principle of algebra is that an equation is a statement of balance. It must always remain balanced. Think of it like a company's balance sheet. Assets must equal liabilities plus equity. You cannot simply invent an asset on one side without a corresponding entry on the other. It would violate the integrity of the whole system.
And this slide demonstrates that principle perfectly. We add our magic number, 9, to the left side, which turns it into the perfect square trinomial we wanted. But To maintain that crucial balance, we absolutely must add the exact same value, 9, to the right side as well. Our original 7 on the right side now becomes 7 plus 9, which is 16. Our equation is now transformed, but it remains perfectly balanced.
This brings us to the payoff. This is the aha moment. All of that careful setup, all of that methodical work was for this. The expression on the left, which was previously just a jumble of terms, can now be simplified into its elegant, intended form.
And there it is, the trinomial x squared minus 6x plus 9 factors perfectly into x minus 3 squared. Now look closely. See that negative 3 inside the parentheses? That is the exact number we got when we took half of our b coefficient a few steps back. That is not a coincidence. It is by design. This is the mathematical beauty of the process. We have successfully transformed a complicated equation into something far, far simpler to solve. So the heavy lifting is complete. The strategic restructuring of the problem is done. Now we simply need to execute the final algebraic steps to isolate x and find the specific values that make our original equation true. To get x by itself, we first need to eliminate that squared exponent. The inverse operation of squaring something is, of course, taking the square root. So we take the square root of both sides. On the left, the square root of x minus 3 squared is simply x minus 3. But on the right, what is the square root of 16? Now pause. Your immediate answer is likely 4. But this is the single most common mistake students make, and in a business context, it could be a disastrous oversight. You see, not only does 4 squared equal 16, but negative 4 squared also equals 16. So we must account for both possibilities, which we denote with this plus or minus symbol. Forgetting this means you will find only half of the solutions. This plus or minus sign forces us to consider two separate scenarios. Let's walk through them. In our first possibility, x minus 3 equals positive 4. To solve for x, we add 3 to both sides, and we find that x equals 7. In our second possibility, x minus 3 equals negative 4. We again add 3 to both sides, and we find that x equals negative 1. These are our two valid solutions to the original problem. So let's just step back and recap the strategy here. We began with a standard quadratic equation that was not at all simple to solve just by looking at it. But through a logical, step-by-step process, we deliberately re-engineered it. We constructed a perfect square trinomial on one side. This single act of transformation was the key. It made the problem transparent and allowed us to find both solutions using straightforward arithmetic.
I think this quote perfectly captures the essence of what we've just done. This is more than just a mechanical procedure. It is a way of thinking. It's about looking at a complex problem and, instead of being intimidated, looking for a way to impose structure, to reveal an inherent symmetry that was there all along. That mindset is invaluable in any analytical field, especially business.
And that is the thought I want to leave you with today. As you move forward in your studies and your careers, you will constantly face complex problems in finance, marketing, logistics, you name it. The challenge, and indeed the reward, is in learning the techniques and adopting the mindset to look past the surface complexity and ask, what is the hidden structure here? What is the elegant solution waiting to be revealed? Thank you.